Hello, everyone. Thank you for joining us for the next session of our Spotlight on GitHub Advanced Security series, Scaling AppSec in the World of AI-Generated Code with Endor Labs. My name is Anna. I'm an event planner for Reactor, joining you from Redmond, Washington. Before we start, I do have some quick housekeeping. Please take a moment to read our Code of Conduct. We seek to provide a respectful environment for both our audience and presenters. While we absolutely encourage engagement in the chat, we ask that you be mindful of your commentary, remain professional, and on topic. Keep an eye on the chat. We'll be dropping helpful links and checking for questions for our presenters to answer live. This session is being recorded. It will be available to view on demand within 24 to 48 hours on the Microsoft Reactor YouTube channel. With that, I'd love to turn it over to our speakers. Thanks so much for joining us today.
Hey, hello everyone. This is Marcelo Oliveira. Glad to be speaking to you all today. And like Anna said, we are here today to really talk to you about some of the challenges and how to scale AppSec in this new world that we're living in with AI generated code. I'm the VP of Product Management here for Endor Labs. And with me today is Jamie Scott, another product manager at Endor Labs. And before I joined the security side of the house, I was an engineer who converted into a product manager, and I used to build solutions like the one that we're using today, like streaming, meeting solutions, etc. And there was nothing that I hated more than a security person coming to me when I'm about to ship my product and saying I couldn't ship because they found a vulnerability either on my first party code or one of the dependencies that we used. And what I want to do today is like share some of the things that we've been cooking, like some of the innovation that we've been building out, and it's going to be very heavy on demos. Jamie is going to be the one who's going to be answering to our demo gods today. But bottom line is, I'm hoping that the things that I had to deal with in the past are going to be now a thing of the past for you all. And so with that, like Jamie, do you want to give yourself a quick introduction as well?
Yeah, my name's Jamie Scott. I'm a recovering security engineer. I've spent the vast majority of my career at the intersection between AppSec and development solutions. And I think one of the biggest problems that we've seen throughout industry is how does AppSec scale in a world where everyone focuses on delivering business value quickly? And as we start to see more and more code shift to the world of continuous delivery and more code being automatically generated, well, I'll let you handle that, Marcelo.
Sounds good. So I promise I only have 2 slides today, so I'm not going to bore you with that. We're going to be moving to demos fairly quickly here. But I think the first question that I wanted to emphasize is why we're talking about scaling AppSec and why it's more critical today than ever, right? And the answer is pretty simple. With the advent of LLMs, and we've seen how the output of new code being produced by development teams across the world has been increasing pretty rapidly. But the expectation is with LLMs that acceleration is just going to compound, and you're going to see an exponential growth in terms of new code being produced as new developers enter the workforce, and like they become way more productive as a result of that. Now, the challenge is that the ability for securing all this code was already deficient, meaning like security teams were already struggling to keep up with the velocity of new code getting produced. And now with this LLM code auto generation, it's just going to exacerbate the problem that already existed, which is this impossibility of securing everything that is coming out from engineering organizations. We believe here that there is a solution for that, but that requires a major transformation on application security as a whole. And what does application security transformation means? That means like, hey, you need to simplify remediation. That means the technology needs to enable and needs to empower developers to really solve the security flaws seamlessly within their development without the complexity and without the noise that existing solutions use to provide to them. I think Copilot is doing a great job here with some of the GitHub Advanced Security capabilities solving those problems for first-party code. But there is basically an unmet problem here, an unanswered problem here, which is how do you solve that for your third-party dependencies as well? And that's what I want Jamie to really start talking to you guys a little bit about, how we are trying to solve those problems and some of the innovation that we've been developing on this field to help accelerate and solve this impossible economics that we've been looking at between securing code and the code being produced. Jamie, over to you.
Awesome. So before I jump into a demo, I really want to start with a story. And it relates to how we can scale application security programs in a way that's meaningful across industry. And when I was leading a DevSecOps team, what I found was that as a security engineer, I would go in, I would find risk, and I would ask teams to fix that. And ultimately, this isn't something that's scalable, because when I would send a list of findings to a development team, they would come back and they would ultimately say, hey, this isn't actually used in the context of my code. This is test software. This is something that isn't actually important. And what they were ultimately telling me as a security engineer was, hey, how do you focus on outcomes over outputs? And today, the big problem when it comes to vulnerability management is that we use an ineffective proxy to risk. Risk is ultimately a function of a vulnerability, the impact of that vulnerability ever being exploited in the wild. So, what's the importance of this application? Is it going down? And a threat associated with it. And at the end of the day, if we're going to create more code faster and enable a junior developer to create more code faster with AI, then we're up leveling our teams. And there's two ways to really help scale AI. First is you bridge the skill gap, you make people more productive. And this is the core promise of Copilot. This is what they're doing really effectively. But the other aspect of that is how do we help not only AI make better decisions, but humans make better decisions to ensure that you remove friction and also continue to bridge that skill gap. So, what I want to do first is I want to show you how you can focus your attention more effectively. And we do that through what I call reachability analysis. So I'm going to do what any security engineer does today. I'm going to focus on high and critical vulnerabilities. I've got 92 in this application. If I send this over to my dev team, they're immediately going to throw up their hands, tell me to prioritize, or tell me to pound sand. And at the end of the day, what next steps do? You ask yourself, is this actionable? Is this not in test code? And I've got 4 things here. But at the end of the day, the question becomes, is this actually used in the context of my application? And if I click here, I can see, okay, I've cut that in half. I can see immediately that I've got a call path to this. The execute SQL helper function calls mchange, which ultimately reaches the extract XML config from default resource function. And this is important because this helps you know that this is used in the context of your application. This is how you start to focus your attention from using a proxy to risk that ultimately isn't necessarily scalable because it overwhelms teams, to focusing your attention on the few things that matter and also the things that matter right now. So the next question becomes, how do you shift this to a conversation about remediation? Because ultimately focusing your attention only does so much when it comes to managing outcomes. And if you send a team 149 things in this example, well, that's 149 things that they're going to have to triage to make the best decision. And the problem is that if we operate on findings or issues today, this isn't scalable. 149 things doesn't look the same as 3 things. So how do we shift that conversation to remediation and remediation in a way that's effective? Because I can fix a large number of these things by just performing a few simple actions. So here, what I have is I have a test application that is intentionally vulnerable. And I can see immediately that I have a couple options here. And these options are upgrades to various versions. 2.12.71 is the latest, but I can see that there's remediation risk associated with it. each of these. And I think one of the biggest frictions when it comes to vulnerability management is actually fear. And no one wants to go in on a Friday night, deploy a vulnerability fix to prod, and pray that it just works. You ultimately need to test it. And we're humans. We need to manage our time and we have families. No one wants to say, let's deploy this emergency fix on a Friday. So, what can you do to manage risk more effectively? Well, here I can see I have 38 findings. 3 are critical, 32 are high. This is what your security team is going to tell you to focus your time on. If I keep 3 high, I have low remediation risk. I don't have necessary evidence that there's going to be a problem. But how does a security team set better expectations with their dev team on level of effort? And we tend to trivialize the update of software because it's just bumping a version, right? But the reality is that there's hidden risk associated with these updates. Not everyone has mature test coverage. Even best-in-class software engineering organizations are shooting for 70% test coverage. And I think the reality in most apps that I've worked with is that they've operated somewhere in the 30 to 60% range. So, how do we manage those expectations and reduce the fear that happens? Because that fear ultimately decelerates us. And if you expect AI to change that fear, well, it's still a human who has to wake up on a Friday night. It's not an AI that says, oh, I'm going to revert this. So, what are we going to do if we're going to set better expectations? I know that I have 35 findings fixed here. 3 are critical. All of them are actually used in the context of my code. This is an intentionally vulnerable app. But if I make this specific update, then this is going to actually create a breaking change that would require me to refactor my software. And the problem is that as a security engineer, I would just say, bump it to this version. It's going to fix the most findings, right? And I'm sure every developer in this audience has experienced this. But if you bump this and it doesn't work, what happens now? You either actually figure it out and pound through it, or you go back and have a priority litigation type of conversation where you need to understand how hard this is to fix. And here, I've got the deserialization POC main function. It's calling class ID resolver, and this has changed. The actual access level associated with class ID resolver changed from public to protected. So because this function is, or this method is no longer actually accessible, the visibility has changed in the application, my client can no longer access this in my third-party software, and therefore it breaks. So I want to pause there. Marcelo, do we have any good questions from the audience, or do you have any questions you want to prompt?
I think not yet, Jamie. But I think one thing that I think it's interesting and worth highlighting on this picture here as well is it's just the fact that a lot of things change, right, on a given library when you're bumping a version, right? But sometimes not all the changes potentially impact my application, right? Like by the way that I use the application. So that understanding how I use this library seems to be an interesting, an important component here as well, right?
Yeah, absolutely. And at the end of the day, just trying to stay up to latest is a reasonable approach. And I look at this in terms of a tax that you have on software reuse. Software reuse has become a $7 trillion industry. Open source is an asset to most organizations. We can't afford to not stay competitive in today's industry. And open source is how we quickly accelerate what we need to do and get a job done. So if you stay up to latest, what are you doing? You're incrementally paying the tax of software reuse, and you are actually going in and saying, I'm going to deal with these breaking changes as they come. Otherwise, a lot of people pay that tax in a lump sum. And that lump sum is, I'm just going to update to latest from whatever version. If it's not broke, don't fix it. This increases the risk and time that a fix will take. But at the end of the day, it's the same tax, and you accept the risk of not using or you accept the risk of not necessarily bumping until you have a problem because of the potential cost savings there in that tax.
Mm-hmm.
So, I mean, you mentioned changes. This change.
Yeah, and Jamie, just one question maybe from the audience here, because I think it's quite relevant as well, is more around something you didn't touch upon yet, right? In terms of the product, maybe we can bring this up later so you don't break our flow, but it's about how do we help software engineers, select better dependencies, basically reputable libraries, right? Like without creating friction for them, right? Like that's one of the common questions that I think we've heard quite a few times as well from other places.
I love it. No, in the world of AI, I think selecting better dependencies is something that's incredibly important, because at the end of the day, when you ask AI to perform a function, you don't necessarily have standard governance controls around that. Sure, you can prompt it with standard governance controls, but if I go to ChatGPT today, I'm just asking it to get a job done, and I'm not thinking, hey, what's the best library to use? So, how do you select better dependencies? I'll touch on that in about 10 minutes, if that's all right with you. And who is that in the audience? We'll make sure to follow up.
Goes by S from.
Awesome. S, I'm going to come back to you in about 10 minutes. Does that work for you? You can't respond to me anyways. Who am I kidding?
It says thank you. So yeah, we're good. Keep going, Jamie.
Beautiful. So the question becomes, what are the changes that I need to handle? Because if AI is generating code for me quickly, I need to scale that. And I need to, ultimately, vulnerabilities are a moving target. I find new vulnerabilities in software that was quote unquote known to be secure yesterday. It was still insecure yesterday, but no one knew about it. Now we're forced to manage it. That's not something that we'll find things faster with AI. And vulnerabilities are being discovered at an exponential rate at this point. We're starting to see an S curve when it comes to discovering known vulnerabilities. And that's because it's easier to find. AI is helping accelerate that. AI is also helping us accelerate fixes and helping us create both insecure and secure code faster. So if I want to update this, what do? Well, I have this change. I need to update 2.9.10.3 to 2.17.2. Well, that has about 80,000 additions and 20,000 deletions, 1,227 files changed. Nobody has the time to audit this. Like a developer is going to just ship the change, pray it doesn't break anything. And if you have the time to audit this, good on you. I am proud. But the reality is that most people live in this world. I've got a depend about alert. It says to make this exact change. And here it tells me I've got the same 38 vulnerabilities to fix, but I can also see this fails the build. So my tests are failing. It's failing on my build step. My Maven clean package fails because I found this breaking change. You can see here it's in the same deserialization POC function. Well, how do I manage that? Because Dependabot's bumping me up a version, and this is a scalable way to do it. And a lot of the times, it'll just be easy to bump versions. But the fear and friction and actual time suck comes from the roughly 30 to 20% of the time where a breaking change occurs. And the important thing to remember here is that a breaking change is going to occur when your application uses that functionality. If a function is removed, which is common, if a function is modified, if the semantics change of that function, or if functionality is added to that function, it can break your application. And a lot of teams don't have the time to audit this to understand everything. So here, I've got the same build. And I want to show you a GitHub Actions workflow quickly. So in this workflow file, all I'm doing is I'm checking out the repository. I'm building the software with Maven Clean Package. and I'm running an exploit against it. And if that exploit is successful, what it's going to do is it's going to write a file called cv.txt to the local file system on the runner. And I'm catting that. And if I fail to cat it, this exploit is obviously unsuccessful. It's going to get a non-zero exit code because I'm catting nothing. So if I now go to try and update to 2.10 where this breaking change is introduced, I'm going to see that because this was changed from public to protected, I get the same build error here. So because I have a build error in 2.10 and up, I need to figure out how to refactor this effectively. And I can also see here in this workflow that this is actually exploitable. I can see that when I run this vulnerability exploit, all I'm doing is I'm calling a deserialization vulnerability. It's a CV 2020-9547 with Jackson data bind. Well, on deserialization, a gadget class is loaded, and this is going to execute arbitrary code. And I can see here, I can cat the cv.txt file, and this is successfully exploited. This is a successful cat. The deserialization vulnerability works. Now, if I have a breaking change and I can't necessarily just fix it without having to refactor my code, I have a few options. Now, in this instance, I'm showing just one vulnerability that has a breaking change associated with the update. And that update, that vulnerability is actually fixed in 2.10, but I'm using the vulnerable function. And how do you say, I just want a quick fix? And in a world of AI generated code, a quick fix is really all that you need when this happens because you can scale your risk management program. Now, the right thing to do and a real remediation is to get to the later version that actually resolves it. You know and can trust that the code that you use repeatably will have a fix. But if I don't have the luxury of time to refactor everything, then it becomes a question of how do I manage this effectively? If I want to just get the criticals out of my system because I don't have the edict of highs yet in my organization, then I can use what Endor Labs calls a magic patch. What we do here is we backport the vulnerability fixes to your code, this version of the software, so that we minimize change. And rather than going through 10,000 lines of code change, I really only need to change 7 lines of code in order to actually address this issue. I'm going to fix the 3 criticals, including the one that I just exploited. And I can now have some peace of mind that I have the luxury of time without this critical exploitable vulnerability sitting in my environment. And how do I do that? Well,
Hey, Jamie, can you show me what changed in this version? Like, and this you're showing an Endor version here. Like, how much has changed here? You said 7 lines.
Yep, 7 lines of code. What we do when we provide this code is that we make this completely transparent to our customers. So these are the exact 7 lines of code that have changed. You're really just adding a few functions and comments at the end of the day. Our build, test, deploy logs are completely transparent to you. I can go and download these by clicking those buttons. We've got a reproducible build that you can then reuse and test to establish some form of trust.
So no breaking changes, right? Like just fixing the vulnerability within the context of that own library itself.
That's correct. So at the end of the day, how do you think about this? Well, a vulnerability fix can have a breaking change, but we're curating these things in order to minimize the risk of breaking changes and manage breaking changes as effectively as possible. And so here, we're patching 3 criticals. If there are breaking changes in those highs as we continue to patch them, then we will not actually introduce that high vulnerability. So what does this look like in practice? Because this is how you actually scale AI code. Because if AI writes me code, I have two choices. I can either check it, put it through my standard testing process, prompt it to be less vulnerable, or I can actually set up the guardrails in order to ensure that even if it gives me a vulnerable piece of software, I'm using something that is going to have those vulnerabilities mitigated. And how easy is that? Well, here, all I've done is I've set up my settings XML file to authenticate. You would do this in any standard environment if you had an Artifactory set up. And I'm connecting to Endor Labs' patch factory. And all I'm doing here is I'm changing the version number from 2.9.10 to 3 to 2.9.10.3 Endor latest. That's going to pull down the vulnerable software, the non-vulnerable software version, and the latest version of that, so that I know as Endor Labs patches vulnerabilities in this version of my software, I'm just going to use them. Now, the trade-off you make here is that your build is no longer reproducible. And that's why when you use a solution like Endor Labs, we do diligence to ensure that breaking changes aren't actually introduced in the scope of our versions. And we provide transparency to ensure that you can audit that. And if you are in the scenario where you are worried about reproducible builds, you can audit exactly what's changed. Now, one of the things Endor Labs does to help scale this AI generated world is we introduce what we call streaming mode, so that, as I showed here, you are adding a version Endor latest to ensure you're getting the latest patch.
Hey Jamie, there was a question also from us on this very topic. He was asking about changes and if we verify, right, like that the changes were successful. So he's saying like the given code, let's say that is thinking more from an LLM using these libraries now, right? Like when they're generating the code, I think that's the use case that S is looking for, is like, how does he instruct the LLM to use safe libraries? Like now, let's say this vulnerability has been fixed on this magic patch.
Mhm.
How can, and his question is more about like, let's say code does not work when he integrates into the product, right? Like, would we be, because of a syntax error of some sort, right? Like how he could provide the feedback to the LLMs, etc. So I think that's the point here.
Yeah, and that's actually exactly what this is. So when streaming mode is introduced, what happens? You are able to pull down through your Artifactory or your Nexus by a patch version by simply changing the priority of how you use your software. So what's an Artifactory going to do? It's going to reach out to Maven Central as a proxy. It might cache versions of a specific library. And in the scenario where it's caching versions or pulling down and proxying to Maven Central, what it has is a priority list in the package repositories that it pulls down. If you set factory.endor labs v1, this is a demo, one is curated for you, but if you set that as a higher priority than Maven Central, what's going to happen? You're going to pull down patched versions, and in streaming mode, you can use 2.9.10.3 without adding Endor latest. So if an LLM gives you code, then that code in that exact version that you pull down can be a patched version from the start. And in that way, even if AI tells you use a version of this to accomplish this task, and you forget to prompt it, hey, let's make sure that this is a non-vulnerable version, you just get the patch. And this is the secure by default manner of scaling an AppSec program. Because if you want to scale an AppSec program, you need to make people make less decisions, not more. Because the more I ask developers do this fix, the less time they have delivering business value, because their priorities are ultimately new capabilities and business value, reducing tech debt, performance, removing bugs, and security, generally speaking, is something that everyone wants to do. But it's not something that everyone has visibility into to make the right decisions every single time. And therefore, it's something that is reactively done, not proactively done in many circumstances. And because vulnerabilities are a moving target, could have been safe yesterday when you made the decision and unsafe today because new information has surfaced. So, how do you scale and how do you make an LLM tell you a good decision no matter what? Well, you make everyone make less decisions. And you do that through streaming mode because you're going to pull down a patched version of the exact same library by just simply changing that priority of your package repository. S, does that answer your question effectively, or am I off mark?
Yeah, and so let's wait while Ask respond, right? Like there is also, Jamie, like the idea, right? Like if you're writing, like I think what Ask is looking for is how he empower the LLM to make the right choices, and what else could the LLM do, right? Like to assist in some of these use cases here. And we know, like now there's information not only about the magic patch, but hey, here's a magic patch like that fixes all these problems. But there is also information about if you're here are all the breaking changes, right, that exist in a given. If I'm trying to make an upgrade from version X to version Y, I have all the information about the breaking changes. So you can imagine a future where the LLM can actually help you refactor that code to adapt to the breaking changes that were performed. And I think another scenario here is also around like the test coverage, right? Like, hey, I'm making an upgrade to this library. I know all the paths in my application now that were impacted because Endor Labs provides you with that visibility. I could leverage that LLM model to say, okay, can you help me build test cases that exercise all these paths here, so that I can be more confident that when I make the upgrade, that the upgrade was successful.
Yeah, so let me give you a quick example of that. Here, I've got a Python application. And in the update of LangChain community, this base loader function was actually base loader load was actually removed. It's being used in MetaGPT through the read data function. This is an open source app and publicly auditable. And because this was removed, this vulnerability fix won't necessarily have something that is easy to just fix. You can use a patch to make less decisions. But at the end of the day, when you think of how do I accelerate remediation? Well, if the expectation is still I need to fix this, AI makes everyone more productive. It helps me do things faster. So, what if I asked, how do I refactor this because something is removed? And I could give that information to an LLM and say, hey, I mean, LLMs take screenshots at this point. I could screenshot this, pop this into ChatGPT, and say, here's my code, here's the function base loader. What's a good way to refactor this? And that's how you start to accelerate AppSec as a whole, because AI has made it easier for us to do something. Now, I would have to sit down, understand what base loader load even did in the first place, understand this read data function and how important it was to my application. And then based on that, I would have to refactor it in a meaningful way. The the reality is that what if there are other paths? And while it won't necessarily be always able to tell me the exact way as a GPT improves, I'm sure that may get to that inflection point. But the purpose is how do I make this easier for myself? And that's where AI helps. This is how you scale AppSec problems today. And these are the problems that genuinely exist from the human perspective. Does that answer the question?
Yeah, I think so, Jamie.
Cool. S, keep it coming. Thank you. Before I move on, I do want to kind of address S's initial question about how organizations can select better software. Because at the end of the day, what happens? If I'm using AI to perform a task, I'm going to ask it, hey, help me write code to perform this task. I'm not going to necessarily specify governance controls and expectations if I don't know. So let's take a common example. One of my friends told me last weekend. He was complaining that there was a member on his team who is incredibly junior, and they were creating a PDF loader function. And he was saying, "Oh, this JavaScript library that he added was completely separate from something that was already in the bundle." So because he added a new library, a bunch of issues were introduced. There were vulnerabilities. There were performance impact because their bundle was larger and therefore the client couldn't necessarily download at the same speeds and it was slower. So there was performance impact by adding new software. And we create software bloat. So how do you manage software bloat effectively? Because at the end of the day, there's two paths that people in industry take. They either use a new dependency, trust that software, and implicitly rely on software reuse. And they can audit that. But generally speaking, a lot of people don't take the time to audit everything in a software dependency that they reuse. So, what if I were to just click here and say, what's a good dependency? What's software that I should be using versus software I maybe shouldn't? So, here I can see that this is an outdated release. I've got a high ratio of unmerged pull requests. But at the end of the day, there's recent and continuous commit activity here. There's recent pull request activity. I mean, this guy is using Dependabot. And this is also managed by Google. So because there's a lot of good things about this software, I'm going to trust this error-prone library far more than I'm going to trust software that is I just pulled off the internet that was published last week from a random person in Colorado. And at the end of the day, the question becomes one, how do you standardize in your organization to reduce software bloat? My friend had that PDF library that the engineer used, but they already had a different library that could have accomplished the same task there. So, how do you start to set governance rules to say, hey, use this, not this? Or in the case of here, this is something that I generally trust and willing to accept. And let's look at mchange here as a quick example. I have the unfixed critical vulnerabilities in this version, unfixed high severity vulnerabilities. Well, great, but the question becomes, hey, is this going to be something that's reasonably fixed shortly? And this is in someone's personal repository. It's got no recent commit activity. No one has closed issues or no recent pull requests. It's not an archive repository. No one's publicly said that this is unmaintained, but you have all the leading indicators of risk to make the assertion, hey, it's got unfixed criticals and highs, and no one's actively committing to this. Code that's not being actively committed can either be really stable code or unmaintained code. We've got indicators to say this is likely unmaintained code. So I think that reasonably answers your question. How do you set up governance controls? Well, you can do that in CI. You can do that in a way where maybe you instruct LLMs on specific criteria and feed that to an AI that has an API that has that criteria. So these capabilities in industry do generally exist. And if you want to select better software, this is what we do is we help to give data in order to help you make more informed decisions so that I'll give you an example of most standard organizations. They have this quote unquote dependency review process. And that ranges wildly from the CTO approves everything to there's a Confluence or a spreadsheet with all approved software to more mature governance controls are technically enforced. This is an example of more mature governance controls are technically enforced so that you can speed up your software selection. And if a poor decision is made, you're told with a quick feedback loop by the CI saying, hey, you shouldn't use this, and custom instructions to say, maybe consider using something like this instead. At the end of the day, though, if we want to improve productivity across our industry, as AI is doing, and scale AppSec programs, we need to automate some of those decision-making criteria. And in this example, I'm probably going to say, hey, error prone is maintained well. It's maintained by reputable people. It's managed by Google. I'm going to trust this guy over something that I don't have evidence is maintained. And maybe there is an exception process. But if we can't slow down our dev teams, it's all about speeding them up. And at the end of the day, if I'm going to speed up my dev teams, I can't have a weeks long review process. I need to have the right controls in place so that review process is the exception and not the rule, so that I can enable my teams to ship things fast. Does that answer your question, Marcelo? Anything to add? Can you guys still hear me?
Yes, I can hear you. I was muted, so I apologize. But yeah, as appreciated, he said that this is spot on, but he had some other questions as well, and I think he's heading somewhere now, so he's gonna catch up the replay. But I think the primary question was Copilot and some of these LLM tools helping you generate code, right? Like, could they also be commenting on your code, such as debloating libraries that do the same thing, or can we solve these issues earlier, right? Like, how can, as the code is getting developed, so maybe we can talk about the IDE experience, right? Like how we can see some of this a plugin into Copilot providing this information early on as people are selecting those dependencies as well.
Yeah, and I would put it this way. When you manage software, it's all about helping you understand how to make right decisions and better decisions quickly, because no one wants to write do a whole pull request only to find out after they commit to the whole thing.
Hey, Jamie, you're breaking up a little bit.
AI can help accelerate that. Oh, sorry. At the end of the day, AI can help accelerate that. But we as an organization and as an industry need to help people understand that we have a journey of things that we can do. And our mission at the end of the day is to remove and reduce developer productivity taxes. And I think as we explore the world of AI, those are the things that our industry is going to figure out. So, like, what could be the future? The future can be a world where AI helps you understand your code base. The future can be a world where AI helps you to make better decisions faster. Maybe it helps you refactor your code in order to remove breaking changes. Or maybe you take the secure by default method. At the end of the day, there's really only two paths to scale AppSec programs that we have. We can make people more productive and perform work faster, or we can make them have to make less decisions. And both approaches are human. AI is the best human augmentation that we have in industry that we've seen in the last 10 years. Open source was the last real major innovation for that. And now we have a dual-edged sword. We have the world talking about secure by default, where secure by default is the path to make less decisions. And a path like magic patching helps you be more secure by default. A path where AI helps you make better decisions is I am refactoring my code. My AI is telling me, hey, why are we pulling this dependency? There are governance controls there to help. At the end of the day, I think this is what industry needs to explore in order to actually accelerate AppSec programs as a whole.
Makes sense, Jamie. Yeah, and by the way, for the everybody on the call, magic patches are not in our free trial, but pretty much everything that Jamie showed and displayed today, if you guys find that there is you want to learn more about it, there is always our free trial capabilities. It's readily available for everyone to use, and like sign up with your business email account or your GitHub account, and let me know if you run into any challenges as well. I think that was it, right, Jamie? Let's see. I don't see any more questions coming up. Are there any more questions from the audience that we can answer today? We'd be happy to.
And I'll kill Inception. Sorry.
All right. Thanks, everyone. I hope this was a great session for you all. And please, you know where to find us. Marcelo and Jamie from Endor Labs. Good to see you all.
Thank you, everyone, for joining. Thanks to our speakers. We're always trying to improve our sessions and your experience. If you have any feedback for us, we would love to hear what you have to say. You can find the link on the screen or in the chat. We'll see you at the next one.